Hi everybody, today we are looking at section 3.32. This is going to be about using critical numbers and the first derivative test to find relative extrema, and we're also going to look at how to use that test and everything we find out to be able to graph. Our goal is to be able to graph without the graphing calculator, but we will use the calculator to check. Remember that critical numbers are the x-coordinates of possible relative maxes or relative minimums of a function. To find critical numbers, first of all, we have to find vertical asymptotes, if there are any. To find vertical asymptotes, we find the values of x that make the function undefined. These cannot be critical numbers. Number 2, set the first derivative equal to 0 and solve. These x values are critical numbers, CNs. Find where the first derivative is undefined. These are going to be critical numbers, unless they're vertical asymptotes. If they're vertical asymptotes, they are not critical numbers. To find extrema using the first derivative test, make a chart using vertical asymptotes and critical numbers to find increasing and decreasing intervals. For each of the following, find the critical numbers in intervals of increase and decrease, then state the relative max or min if possible. All right, so number 1, we've got our function here. We're going to take this derivative. We get 6x squared plus 6x minus 12. I'm now going to set that equal to 0 because I want to know where is it that slope is 0. I can go ahead and divide through by 6 since this is set equal to 0. And I get x squared plus x minus 2. Go ahead and factor that. X plus 2, x minus 1. So we're going to have critical numbers at x equals negative 2 and at x equals 1. So those are going to have to go in our chart. Now, because I have 2 critical numbers, I'm going to have 3 intervals. So I'm going to have to add on another interval here. I'll just go like that to add on an interval. So my first one is going to have to go from negative infinity to negative 2. Then we're going to have to go from negative 2 to 1, and then from 1 to infinity. So I use those intervals as breaking points. Now I'm going to find a test value. So a number that lies in this interval could be negative 3. I'm going to plug that into my first derivative. I can plug it in here, I could plug it in here, or even here. I think here's the easiest. Negative 3 plus 2 is negative. Negative 3 minus 1 is negative. So I'd have a negative times a negative. That's a positive. So my function is increasing. Between negative 2 and 1, an x value I could use would be 0. Plug it in. I'll plug it in here this time. That's going to be 0 plus 0 minus 2. That's negative. That's going to be decreasing. From 1 to infinity, I'm going to plug in the number 2, plugging that in here. 2 plus 2 is 4, positive. 2 minus 1 is positive. Positive times a positive is a positive, so therefore we are increasing. So because we're going from increase to decrease to increase, we are going to have a relative max. See, if I go from increase to decrease, I have to have a relative max here at negative 2 back into the original. Negative 2 cubed is negative 8 times 2 is negative 16. Negative 2 squared is 4 times 3 is 12. Negative 2 times negative 12 is going to be plus 24. We're going to have 36 minus 16, and that is going to give us 20. So we're going to have a relative max at negative 2, and I'll make this go by 5, 10, 15, 20, at negative 2, 20. Okay? Now, because we now go from decrease to increase, we're going to go down to up, we're going to have a relative min. That relative min is going to be at 1. Plug it back in here. 1 cubed is 1 times 2 plus 1 squared is 1 times 3. Negative 12 times 1 is just minus 12. So 5 minus 12 is negative 7. So at 1, and then I'm going negative 5, negative 10. So negative 7 is right about there. That's going to be my relative min. Now, I should also find any intercepts if I can. So if I plug in 0 for x, I get 0 for y. So I know I have this point of 0, 0. Okay? That should be pretty much enough. I could also find intercepts by setting this equal to 0. Let's go ahead and do that. We'll see if we can. So if I set this whole function equal to 0, I'm going to factor out a 2x. I've got x squared plus 3x minus 6. Okay, I can't factor that. easily, so I'm just going to not worry about my other intercepts. I'd have to use a quadratic formula to set that equal to 0 and solve. So we're not going to bother with that. Basically, the function's going to go up. There's the max. It's going to go down. There's the min, and then it's going to come back up. And if I wanted to check that out, I could on my graphing calculator. I just go to y equals, put it in there, 2x cubed plus 3x squared minus 12x. Do a zoom 6, and it should look similar to what I've got here. And there it's going up and then down and then up. And if I wanted to make it look exactly the same, I just go to my window. My x's, the x's are fine, but my mins are going from like -10, and then it's going up to like 20. So I'll make it go a little higher, like 25. And now it should look pretty darn close to what I've got. Okay, makes sense? All right, let's come down here now. Find critical numbers, relative maxes and mins, intercepts, asymptotes, and graph. All right, so first of all, I look for any asymptotes I might have. Because this is a rational function, whatever makes this undefined is going to be a vertical asymptote. So I'm going to have a vertical asymptote of x equals 0. The next thing I'm going to go ahead and find is whether I have any other asymptotes. Well, I don't have a horizontal asymptote because these degrees would have to be the same, or the degree on top has to be less. When the degree on top is higher, that means I'm going to actually have a slant asymptote. To find that slant asymptote, I'd have to divide x into x squared plus 1, and I have to use long division. So x squared divided by x is x times x is x squared, and then that's all I can do with that. I'm going to subtract, and that's gone. I bring this down, this is 0x. 0 divided by x is 0. So I just stop right there. My slant asymptote is y equals x. There's nothing else I can do. So here's what I have so far. I've got a vertical asymptote here at x equals 0, and I've got the slant asymptote of y equals x. All right, so now I'm going to go ahead and find my derivative. So I have to use the quotient rule. F prime, 2x. So derivative of the top times the bottom minus the top. Derivative of the bottom is 1 all over the denominator squared. That's going to give me 2x squared minus x squared minus 1 all over x squared. And that's going to give me x squared minus 1 over x squared. So my critical numbers are going to be whatever makes this undefined, 0. But that's already a vertical asymptote, so it can't be a critical number. So my critical numbers then are going to be whatever makes this equal 0. So I just set the top equal to 0. If I have x squared minus 1 equals 0, I factor x plus 1, x minus 1. So -1 and +1 are going to be critical numbers. Now, up here I have a little room. I'm going to make my chart up here. What goes in my chart? Well, the vertical asymptote must, as well as those critical numbers. So I am going to have to make these intervals go from -infinity to -1, from -1 to my vertical asymptote of 0, from 0 to 1, and from 1 to infinity. See, my vertical asymptote has to go in there as well as my critical numbers. So now I'm going to have my test values. So I could test -2, -1/2, +1/2, and 2. Now I need to know whether it's positive or negative on that. So if I plug -2, I'm going to plug it in right here into my first derivative. I need my prime on that. So -2 squared is 4 minus 1, that's positive, over a positive, that's a positive. -1/2 is going to be 1/4 minus 1, that's negative. Anything squared is positive, so negative divided by a positive. Plugging in 1/2, 1/2 squared is 1/4 minus 1, that's negative. 2 squared is 4 minus 1, that's positive. So my function is going to be going increase to decrease, and then decrease to increase. So let's get some points in here now. So I want to know, I know if I go from increase to decrease, I have to have a relative max at 0, -1 rather. Let me get rid of that. -1, plug it back into the original. That's going to be 1 plus 1 is 2 divided by -1 is -2. I have to have a relative max at -1, -2 right there. And now I just read my graph. From -infinity to -1, I have to be increasing. From -1 to 0, I have to be decreasing, so it looks like that. Okay, now I'm going to have, I go from decrease to increase, so I'm going to have a relative min at 1 comma, back into the original, that's 2. So at 1 comma 2, I got to have my minimum, relative minimum, and I have to go decrease from 0 to 1, and then 1 to infinity, increase. And so that's the way the function has to look. Okay? So notice too how this maximum is actually a smaller value than that minimum was, and that can happen when we have that vertical asymptote. So just to kind of show you this, x squared plus 1 divided by x, zoom 6, and here's what we've got, and we were correct. Okay? So hopefully that helps you to figure all this out. We wanted to get all this stuff in here. This is our important information. And that would be an intercept there. Okay? All right, so I hope that helped. If not, make sure you ask questions about it.